Why a temperature controller keeps oscillating? A temperature controller reaches the set point, then shoots above it, then below it, and keeps repeating. Most engineers blame the heater. The real problem may be PID tuning. So what is the function of PID? P controls how aggressively heater reacts. I removes steady state error, and D predicts the temperature movement before it happens. Tubular heater stores heat and it keeps releasing after power is turned off. This will cause the temperature to overshoot, and your PID must compensate for this delay. So let's see how step by step we can tune PID values. Step 1. Start simple. Just turn off your I and D values and set both to 0. Now we will start with the P, but the P value should be low. Let's say we can start with 5 to 10. Goal is to reach set temperature with small oscillation here. Step 2 will be finding the optimal value of P, that is proportional. Increase value of P gradually, double each time, like 5, 10, 20, 40, 80, and watch response which you are getting. Watch when it starts oscillating. When oscillating, reduce its value by 50%, and the value you will get is the value of your optimum P. Higher the P value leads to oscillation. Lower P value leads to slow response. Step 3 will be finding the optimal value of integral. Let's set I values and start with 0.1, then 0.2, 0.3, 0.4, 0.5, 0.6. Increase it until the oscillation reduces the set point. When it starts oscillating, cut its value by 50%. That's your optimal integral value. It eliminates steady state error and keep it as low as possible. Final step will be finding the optimal value for D, that is derivative. Start with 0.5 to 1. What it does? D reduces overshoot caused by heater inertia, which is important for tubular heaters. If overshoot is still high, increase D slightly. It anticipates changes and breaks the response. It plays critical role in tubular heaters as there is a high thermal inertia and they are slow to heat up and cool down. Most engineers start by changing PID values, but if heater inertia and sensor location are wrong, PID tuning won't save your system.